Good afternoon. In lecture 7 of metallurgy, we will be discussing today about Hall-Heroult process for the reduction of aluminium. So this process of Hall-Heroult is used for the reduction of aluminium, and here alumina, that is Al2O3, is reduced to its corresponding aluminium metal in the liquid form. So we will see the setup, that is the process involved is the electrolytic cell, that is electrolysis of alumina is taking place. We will see the setup and we will understand in detail. So if you see this setup, so here this is an electrolytic cell for the extraction of aluminium. So this electrolytic cell, if you see, this is a steel vessel, and this steel vessel is lined with carbon. So the lining of the carbon to the steel vessel will act as the cathode, whereas the copper clamp which is holding these rods are acting as are graphite rods which are acting as anode. So these two electrodes, that is the lining of the steel vessel with the carbon, acts as a cathode, and this graphite rods will be acting as the anode. And if you can see here, both the cathode and the anode are connected to the terminals of the battery. Here anode is connected to the positive terminal and cathode to the negative terminal. Now what is happening in the process of electrolysis, we will understand now. So here in the vessel we are taking Al2O3, and this Al2O3 alumina is also mixed with cryolite, that is Na3Al6, or fluorspar, that is CaF2. So both alumina and cryolite or fluorspar is added because here alumina in the solid state, here the electrolysis is taking place in the molten state. In order to make the metal melt, to lower its melting point temperature, we are adding cryolite. So this cryolite, the purpose of adding cryolite or fluorspar is in order to make alumina to lower its melting point and make it into the molten state, that is into the liquid form. So when it is in the molten state, the electrolysis process starts. So once the battery is on, what is happening? The alumina which is in the molten state gets converted into its aluminium ions and oxygen ions. So what are the reactions which takes place at the cathode and the anode? We have to see separately. So at cathode, as you know, at cathode, what is the reaction which takes place at cathode? Cations will move towards the cathode and reduction takes place at cathode. Whereas at anode, as you know, anions will move towards anode and they undergo oxidation. So if you study the reactions of at cathode and anode, they are here as follows. So here at cathode, as the aluminium ions, Al+3 ions are moving towards the cathode, they undergo reduction. By taking 3 electrons, aluminium is getting converted into its liquid form. So this ionic form, cationic form of aluminium is getting converted into its pure metal aluminium in its liquid form. And whereas at anode, the oxygen ions, which are the negative ions of the alumina, they are going towards the graphite and they are undergoing oxidation. So carbon reacts with the oxygen ion to get converted into carbon monoxide gas, and giving so the evolution of carbon monoxide gas takes place with 2 electrons given out. Or it can also take place that carbon with 2 oxygen molecules, it may combine, 2 oxygen ions, it may combine and get converted into carbon dioxide gas, giving out 4 electrons. So here this is the process of oxidation and reduction at cathode and anode. So here that is how the oxidation, the reduction and the oxidation takes place at cathode and anode. So along with the aluminium ions, we also have the other ions like sodium ions, and or if you are taking fluorspar, that is calcium fluoride, calcium ions may also be present. But here only the aluminium metal which has high reduction potential will go towards the carbon and undergo reduction. Whereas here oxygen will go towards the anode and undergoes oxidation. So what is happening, if you see the setup, the liquid aluminium will settle here. So this is your molten aluminium in its pure form is collected at the bottom of the tank, and this aluminium is flowing out through this outlet outside. And here we are collecting our pure aluminium. So this is the setup of electrolytic cell, and this is how the extraction of aluminium takes place by using Hall-Heroult process. And these are the reactions which are important. At cathode what is happening and at anode what is happening.